Here we're going now with a third presentation on mountain flying. We've done a little bit now to say hi and the density, and we had a look at wind. So let's look in the third part what I was talking about here. Here we're going to talk about the approach profiles, level approaches, crosswind and contours and stuff like that. All right, so remember I was laying the table with the environmental indicators, and now we have to start seeing, all right, we've now got the environmental indicators. Now, what are the flying methods that we're going to use? And you'll see that everything is there to avoid the bad spaces where the wind is going to adversely affect ourselves. Oh my goodness. All right. This was also in the Drakensberg, not so high. Well, here you can see it was only 4,500 feet above. You can see that we're airborne, everything is going there. And here we've got this beautiful waterfall, and we are looking at the speed, and you can see that we are hovering there, and I took the picture. Now, that was just to show off how nice it will be if you can do your mountain flying. Level circuit approaches and landings. All right, let me see. This approach and landing follows the same pattern as a normal circuit, but is flown at a height or slightly higher than the landing area. Whoa, okay. Level circuit approach and landing. Okay, let's see here. During the final approach segment, the helicopter is brought into the hover next to the landing area with ample breakaway to escape the ruse. Oh, okay, whoa. What we are saying is that, let's have a little bit of a drawing here quick. If I look at the mountain from the top, and I've got the areas here of the mountain, you come in with your helicopter now, and you slightly higher, but you actually go and you get into the hover there, where the wind has got no effect, and then you can come straight over. Considering obviously the demarcation line, because that's going to be the whole idea. All right, let's just, now that you've got plus minus an idea what we're talking, the pilot is to face into wind. Well, as I've said, the helicopter must be faced into wind, and with no mountain area in front of him, he would not have any turbulence or downdraft. Look here, clear air, hover, nothing in front, no up and down drafts to worry, and that should be pretty much okay. And the pilot is to perform an out-of-ground effect hover check to ascertain power available to perform the final maneuvering and landing. Hey, this is very important, and obviously that must be into wind. Whoa. A lot of guys coming from the coast, and you do quick stops. Up in the mountain there's no such thing. All right? It's slowly you get the machine into the hover, and you get into the hover with your power, and you continually check on, have you got enough power? Because your free air hover is with spare, because remember, you must have your breakaway. Well, you know, here I am, there's the pinnacle I want to land, I'm coming into the vent. If anything happens, I'm going to break off to the right, and trying to get into the hover, I see it, power is not sufficient, I can break off. Or if I've got an NRDK, the main rotor RPM goes down, I can go just ever so slightly, but I can get forward speed. Another lecture, I suppose. The pilot is to perform an out-of-ground effect hover check to ascertain the power, having positioned himself just above and next to the landing area, just above. He is to fly the helicopter across, still facing into wind, to above the landing area. Now, look. What I'm saying here, you sitting in here, let's say this is where the mountain is. You come in, do your cross hover and everything. You maintain the nose of the helicopter into the wind. You move over to, and you can touch. Many a times you can't land, but if you can get one skid on, somebody can get on, and then you will take off, clear your air, and you go forward. Just make sure, because obviously you want to be in clear area, so that you obviously don't want to get into trouble at that stage of the game. Okay, So let's go on to let's have a look here at the level approach. All right, I'm just going to go onto this to make it a little bit bigger. There I put a leeward side, downdraft side, and come in with a helicopter until the height that we were talking about, the height, get into the hover and land. Now, this is fine. What we have to do is just look. This is pretty much okay, but we need a different drawing. So first let's get, okay, it's just one of those, the plateau landings, and that is normally quite a bit easier to be able to do that. All right, this is where I wanted to be. And to say that the clear areas, I am just about 100 foot higher than the top here. I fly in the clear area there. I do a hover check. I see if everything is fine. And then I move over here, keeping in mind the demarcation line, so that wherever I'm I can break off into the side where the wind is coming from. All right, that is going to my plan B if I need to break off. There is the helicopter coming and the helicopter coming and the helicopter across, and that is what we needed. And here I've got just a little bit. Oh, all right, okay, no advertising. I suppose considerations and cautions. Right, let's have a look at the first note there. Density, altitude and power calculations must be built prior to the sortie. You can't get up there and find that you cannot do the job that you went up there to do. You have to plan beforehand. Now, if you are only going to fly half an hour, then you don't have to take 3 hours kind of, fuel. If it's going to be half an hour in and out, then yes, you're going to have another 15 minutes or so spare, but you don't have to have much more than that, because the nature of helicopter is not that you're going from here, which is in the southern tip of Africa, to Paris. It's not what you're going to do, okay? So all the millions of extra fuels, we can't do that. We can't do that, because the extra weight that we can carry is to be able to do the job while we are there. All right, density, altitude. The hover check must be clear of air affected due to the interaction between the wind and the mountain terrain. That is quite clear. You cannot do that in an updraft, because you're going to get the wrong indication of your powers. You don't want to do that in a downdraft. You want to do that on a path where the playing field is, so to say, level, or then as level as possible. If you do it on the upwind side, then you must be able to use the upwind side under all circumstances, because any maneuver then that puts you on the downwind side is the power is going to be, well, it's not what you worked out. It's going to be wrong, okay? You're going to pay for it. The pilot is to maneuver the helicopter below and towards the updraft side of the demarcation line. Caution, the downdraft side of the landing area must be avoided. Should a sudden increase in power requirement be detected, the pilot is to break away and avoid the downdraft area. Whoa! What? Here I'm sitting and I'm busy checking, and all of a sudden I get a rate of descent. Well, what are you trying to do? Break off. Let's come again. Now we're a little bit more clear and we'll feel it. Oh, no, there she goes. And out we go. All right. Yeah, but I have to pick that person up from the mountain. Well, mountain rescue helicopter pilots surely cannot just have had a basic mountain flying course. They shouldn't have had, and they've done a little bit of training up in the mountain, and they understand what that is all about. There are more than one method to get in there. But remember, if you're caught in a downdraft without enough or sufficient power, and you've got mountain in front of you, you are going to blend with the mountain. Short one. See you in the fourth presentation on the mountain.